Lesson 6 of the Enhanced Electric Power Quality and Reliability series, and this lesson focuses on system integration. So we've talked now pretty much from the telemetry, instrumentation, getting the data up into the control room through a SCADA system, and the protocols that the devices out here in the field are going to use to talk to the central control system. And so now we want to talk a little bit about how the data flows from inside this system to the outside world, so that different people in the company, or even maybe different people in different organizations, can use the data and get the information that they need to do their jobs. It's important to notice or to realize that industrial control systems, or SCADA systems, are built specifically to safely control and monitor a process. Okay, so when I go and I buy a SCADA system from, say, Siemens to operate my electric grid, its primary goal is to allow me to safely and effectively control and monitor my electric grid. Okay, it's not necessarily concerned with getting the data out to the environmental department who needs to make environmental reports, or to get the data out to an engineer who's going to report it to NERC and FERC, or something like that. It's built primarily to safely monitor and control the process. And so it's comprised of the control devices, the human-machine interface that we've talked about, the alarming consoles and stuff like that. And all that stuff is located inside a security perimeter, okay? Because we're controlling real world devices out in the field and lots of power. So it's really important that I maintain my security perimeter, that somebody from outside that isn't supposed to be operating any of this equipment can't get in there and either accidentally or maliciously do something that's going to cause harm to people or damage to equipment in the field. So the problem that I have, though, is in the real world, it's never enough to just have all this information contained inside my control system. People outside of the control system, people outside of the control room, need this data to perform their jobs. There's very useful things that they can do with this data. And so I have to find ways of being able to deliver the data to them without compromising my core mission, which is to safely and effectively operate that equipment. And so this problem is it's often referred to as information silos, and it's not just an industrial control system or a SCADA problem. It's a general IT problem. Okay, so we're talking about system integration here, which is gluing together these systems and allowing them to exchange data. So talked a little bit about some of the reasons that people might need this data outside of the control system. And so I might have technicians that are in the field that need to do troubleshooting. And so sometimes it's helpful for them to be able to look at what's happening in the system. They don't need to control it. They're not operating it, but they just need it to troubleshoot, to figure out what's going wrong so they can fix problems. That's one of the reasons. Another reason is there's all kinds of reporting that's required. So if you're managing an electric company, certainly you're going to want to get reports about the amount of electricity you're producing, the amount that your customers are consuming, and things like that. And so you're going to have production and operation reports that center around that kind of information. You might also have some sort of environmental compliance regulations where you're required to take certain measurements and report them. And so I spend a lot of time in my business helping people deal with these environmental compliance reports, and to collect the data and put it together in a coherent format so they can report it. And then there's also stuff like the National Electric Reliability Council, I think is NERC and FERC. And so you're going to have to report certain measures of your electric grid to make sure that you're operating it properly and effectively, and you're doing your capacity planning and keeping ahead of growth and stuff like that. And so people are going to need to report that. And of course, your engineering staff is going to need to see how the grid is operating. They might use operation information to plan future enhancements. or to plan fixes for problems that you have with your grid. And so engineering is always going to need to be able to get to the data. So in order to get this information out of the SCADA control system and to the rest of the company, you have to find some sort of a common language. And this is just like on the protocol side, the industrial protocol side, you've got to be able to use the different protocols and the common protocols in order to get two parts of the system to talk together. It's basically the same thing. You know, you have to find a common language. And the process of engineering a solution to this problem is usually referred to as system integration. The people who do it are system integrators. So I'll tell you a story. The first energy management system that I was ever exposed to was an ancient one, and it was completely custom hardware. This was back before you could just go buy servers off the shelf and put them together and put your programs on them and plug Ethernet cables in and make it all work. This was back when Harris actually had to build the computer systems from scratch, put all the software on it, and make an energy management system to control an electric grid. And so my client, or this was actually my employer at the time, had this ancient system, and they needed to get data out, just like for the reasons we've already been talking about. So people needed to be able to see just the basics of, you know, how much power was being used and how much power was being distributed, and they needed to get this to other parts of the company. There's absolutely no way to do this. You couldn't just take a PC back in those days and plug it in and write a little program. And what they ended up doing was they had an old daisy wheel printer that was hooked to the system, and they actually rigged up another computer to sit there and pretend to be the printer, and they programmed the energy management system to print out this report, and that computer sat there and pretended to be the printer and read the report basically, and then got it onto the rest of the network. And that was the only way that they could get data out of this system. So we've come a long way since then, but this was not that long ago. I mean, it's been 20 years ago, but in the grand scheme of things, that really isn't that long ago for how far we've come. So I want to talk about different ways that you can exchange data through systems, different things that I've seen people do. And one of the things that they'll do is you'll have your proprietary control system, and it knows how to write to a database. So you'll have a database server, and you'll have your control system write to the database, and then your other programs outside of the control room can go read from that database, and that's how the data's passed. And this is still a common way for people to do it. You know, and the good thing is that the vendor who supplies the control system just needs to know how to write to that database, and then you just need to know how to read from that database, and now you can exchange data. These days, or actually even this is kind of old stuff, but it's more recent than the original or the first example I gave you of using the printer. Because of this need for system integration, the control system vendors were pressed by their clients to produce a way of programmatically exchanging data. And so what would happen is now the control system vendor would publish a set of code libraries, and they would call it an API, an application programmer interface. And so they would say, hey, if you want to write some C code, you can use these functions we're going to give you, and you make these function calls and you'll get the data. So again, you're writing C code basically, and I included the cover of the old Kernahan and Ritchie C programming language book here. That anybody my age has this book sitting on their shelf somewhere because they use this book in school. But this would allow you as a client to sit down with a computer and a C compiler and write some code to get data out of your control system. Okay, another thing that they call APIs or SDKs, a software developer kit. So you've either got an application programmer interface or you've got a software developer's kit. Basically, they're kind of the same thing. But again, here's what it looks like. You've got your proprietary system here, and you've got your computer over here, and you connect them together somehow, and then you write your custom application using the API or the SDK, and now you're able to get that data into your enterprise. So the bad thing about doing it this way is every control system vendor is going to have a different API or SDK. So if I have a Siemens energy management system that's 15 years old and I've written a bunch of programs, and then I go to upgrade it and I get a GE system, well, all my code has to be redone. So that's a huge disadvantage to this approach. So obviously one of the problems that I run into is if I have multiple control systems or my control systems change, I'm stuck with learning the intricacies and the details of another API or SDK. And I might not have just one control system in my company. I might have five different five different control systems. So I might have five different APIs or SDKs that I have to master in order to do the programming. So this becomes a huge impediment. And so a solution's been developed over the years, and this one of it's become the lingua franca, the common language of control systems, and it's called OPC. And this is based on a Microsoft technology, and Microsoft used to call it OLE, which was object linking and embedding. And what this was a programming specification that allowed programs to embed different objects in them. So you could have a Word document that had a chart from an Excel spreadsheet embedded in it. That's how this started. This became later known as the component object model, which was a programming specification for program objects. And then it became DCOM, distributed component object model, which was a specification for allowing you could write computer libraries or computer objects on two different computers, and they could communicate across the network. So using this Microsoft DCOM standard, they developed a communication protocol called OPC that allowed you, it was a standardized way of communicating tag database between an OPC server and an OPC client. Okay, and there's the opcfoundation.org. This is an open specification. Lots of different manufacturers of control systems and control system software belong to the OPC Foundation. And so this abstracts my proprietary system and my API SDK calls. I write an OPC server using these API and SDK calls, and then anybody can communicate with my OPC server in a very standardized way using the OPC protocol. And so the nice thing about this is if this is my Siemens control system, say, and I have an OPC server that talks Siemens on one side and OPC on the other, then later on I could buy a GE system here, and I could replace this OPC server with an OPC server that talk the GE protocols on the back end, but it still talks to me using the OPC front end. And so I don't have to rewrite all my code. If it's been written to use OPC, it's transparent to me what's talking on the back end. I've got a common way of talking on the front end. And so OPCs have become very valuable in the control system industry, because now I can develop, let's say I develop a program that does some certain type of analysis, or maybe I've developed a program that charts something for me. Can chart data from a control system. I can build it as an OPC client, and then as long as there's an OPC server available for the control system, I can talk to any control system. And so the cool thing is now is that OPC has become so popular and so widely available that it's virtually impossible to buy a control system these days that does not have an OPC server available for it. And so it doesn't matter if I go into a client and they've got some control system I've never even seen or heard of before. If they have an OPC server available for it, then I talk to it using OPC, using my common tools that I'm used to dealing with, and I don't have to know any of the details of the back end. So as a system integrator, this is fantastic because it allows me to learn how to talk to control systems in one way, and the back-end details are totally masked from me. So now I can get tag information back and forth between my systems easily using the one way of doing it. And the back-end stuff, there just has to be one engineer somewhere that's written the code to translate the the common language to the proprietary language and back and forth. So one person does that, and then everybody on this side benefits. So it's really been fantastic. Another way of doing this type of system integration is through web services. Okay, so web services are just like you would expect, based on World Wide Web standards. So HTTP and HTTPS, just like you use in your web browser. And what you do is you set up a web server, you make your HTTP request, and the data is returned to you in an XML document. So XML is Extensible Markup Language, or XML, and it's just a text-based format. So it looks something like this.